we have one final bit left before we actually have the complete classical definition of an extensive form game. There's one bit left, which is we want to be able to augment the game with something that says that the game can sometimes change state completely outside of the player's control. So, for example, if you're modeling a game where sometimes the players roll a dice, that is something which is outside of the control of any player. So these are called moves of nature, and it is standard in game theory to arrange that all of the randomness happens up front. So as to say, we do one big piece of randomness at the beginning as the first move of the game, and then after that, everything happens according to what the players choose. And I'll show you in a bit kind of how we can do that, generally involving using information sets to make sure that nobody is aware of the randomness until they're supposed to be. So we're going to say that the root node is no longer just the root node, not any other nodes. The root node is going to be owned by a kind of dummy player, which isn't one of the actual players of the game. And this player is conventionally called nature. And the thing about nature is that nature is going to play a mixed strategy profile. So mixed strategy profile is just going to be a probability distribution on the outgoing edges of the root node. And that strategy profile is going to be common knowledge to all of the actual players. So in that sense, it's part of the game. So what's going to happen is when the game starts, something purely random and known to the players is going to happen, that the game is going to transition into one of several states. And then once we reach that point, then the game is going to continue as it always has done. But note the nodes which are immediate successors of the root node could belong to information sets, which mean that although the randomness has happened, the players aren't aware of it yet. So this is kind of like rolling a dice, but keeping it hidden and then only revealing what the roll was later. So here's an example. I've started to draw examples which are kind of sketches where I'm missing out. I've missed out a lot of labels here. I haven't labeled actions, and I in particular haven't labeled any payoffs here. So this is really a kind of a family of games waiting to have some extra information attached to it to complete it. But this is the shape of what's called a signaling game. So what happens here is that in the root node, nature moves first and then can transition into one of two different states. And player one is able to observe that. So player one knows whether nature went left or right. But now, so player one can then choose two different moves. And they're allowed to, because they know what nature did, they're allowed to do two different things in these two different nodes. So they could go left here and right here, for example. But now these information sets are set up so that player two knows what player one did, but doesn't know what nature did. So if you see player two, if they're here, as far as they know, they could also be here. And in both these cases, player one moved left, but they differ in that nature went left or right. And similarly here, in both of these, player one moved right, but player two doesn't know whether nature went left or right. Now, the reason that this is called a signaling game, and I'll probably come back to this in a couple of weeks in more detail. The reason that this is called a signaling game is that through player one's strategy, player one is able to kind of implicitly reveal what nature did by playing a strategy that is what's called signaling. So if player one is playing a strategy that is going left if nature goes left and going right if nature goes right, and player two knows it, then by player two, by observing whether player one went left or right, can kind of infer what nature did, so they can kind of gain new information through inference about where they are in their information set. Okay, That's very hand wavy. So I'm going to come back to this in kind of mathematical detail in a couple of weeks, I think. So here's an example where I demonstrate how we model if we want randomness to happen somewhere other than at the beginning, how we can kind of fake it. So suppose we have a situation where player 1 moves and then some randomness happens and then player 2 moves. And we say player 2 wants to be able to observe both the randomness and what player 1 did. So player 2 knows everything. What we can do is we can interchange the randomness and the move of player 1. So we're going to say that actually nature moves first and player 1 moves second instead of the other way around. And then we're going to use an information set to say that whenever player 1 moves, they just don't know. So they have to move as though they don't know whether nature went left or right. But player 2 only has singleton information sets. So in every case, player 2 knows everything. They know whether nature went left or right, and they know whether player 1 went left or right. Okay. And in general, you can do this kind of thing with more complicated examples. It's just that the trees get very big. I should say there's no inherent reason why we can't have nature moves later in the tree. This is just kind of tradition. I guess it makes some of the analysis simpler if all the kind of randomness happens at the beginning. Okay. Now there's one other kind of correction we need to do, which is if we have nature in our game, we need to change again the definition of the normalization, and that again is going to have knock-on effects for how we define Nash equilibria. So namely, in some cases where we have a player can make a choice unaware of some randomness because of an information set, and then we play out this strategy, we're going to have to take the expected payoff. So, sorry. So this is a one-player game. So we just have player 1 can choose left or right in these 2 different states, and they get payoffs, which I'm going to call A, B, C, and D. And then we have nature moving left with probability P, right with probability 1 minus P. If we normalize this, we're going to get basically a 2-by-1 matrix, because all we have is 2 choices for player 1, namely left or right. And so we want to say, for example, the payoff that we get if we evaluate the strategy to go left is going to be the expected payoff from going left, which is going to be P times A. So that's the possibility that we come this way with probability P. And then 1 minus P, there's a mistake here. There should be 1 minus P times C, which comes from going this way. Okay. So one last trick I'm going to show you. If you remember back to a couple of weeks ago, we talked about a thing called correlated equilibrium, which is where we had a randomizing device, and the randomizing device was sending signals to the players, and then the signals were kind of correlated according to some joint distribution. We can simulate this as an extensive form game with imperfect information and a move of nature, where the randomizing device becomes the move of nature. So let's say we have a 2-by-2 by matrix game, and then we say we have a randomizing device where the 2 players have 2 different signals each. So let's say the 2 signals for player 1 are called S1 and S1 bar, and the 2 signals for player 2 are called T1 and T1 bar. And so in combination, there are 4 different states that the randomizing device can be in. And the device itself is defined by a joint distribution on these 4 outcomes, which is exactly a strategy for nature in this game. And then if you look carefully at this tree, I have set things up so that player one exactly knows their signal. So in both of these cases, we have the signal for player one is S1, and they don't know whether player two gets T1 or T1 bar. And in this case, player one gets S1 bar, and they don't know if player two gets T1 or T1 bar. Now, after this, so now we have bigger information sets. So we have player two has two information sets, both with 4 nodes in. So one has this node, this node, this node, and this node. And the other one has this node, this node, this node, and this node. So this is actually the first example I've shown you where we had information sets with more than 2 nodes in them. So this is now set up so that player 2 can exactly observe whether the original signal from nature for them was T1 or T1 bar, but they don't know whether the signal for player 1 was S1 or S1 bar, and they also don't know what move player 1 made. So hopefully this gives you an idea of the kind of art of information sets, how you can start kind of carving up the tree in order to gain very fine control over the knowledge of players at different points in the game.